Ta-da! Earth's orientation. 23.5 degrees, just like the incline of the zodiacs. However, we are not the strangest. When I first learned that we're not straight up and down, I thought that was kind of strange. And I'm like, wow, the Earth is a little bit odd. The Earth is a little bit odd, but that's not why. We're at 23.5 degrees. Uranus, I know, it's Uranus or Uranus. They're both not awesome, so I'm just going with Uranus. Uranus is on its side, 97 degrees. Technically a little bit more than on its side. Venus is almost completely upside down at 177 degrees. So, keeping that in mind, 23.5 degrees, not all that nuts. Although this 23.5 degrees does have a lot to do with our seasons, as we'll see here soon. Okay, so here we are. Here's the Earth, 23.5 degrees, and then you can see lines of latitude, right? The equator being 0, and then the 90 and 90 being the poles. But look at how the sun's rays are portrayed as hitting the Earth, right? There's a line in the middle that separates light from dark, called the circle of illumination. Oops. Now, here's the Earth and the sun, right? The Earth going around the sun at different times of the year. This explains equinoxes and solstices. Equinox, really easy to remember. Equal, nox, meaning night, equal night. So basically your days and your nights are the exact same length. Solstices mean shortest days or shortest nights. We'll talk about all these in depth in just a second. Alright, so first one we're going to talk about is the solstice. The summer solstice happens in the summer. June 21st, June 22nd, one of those two dates. Okay. If I were to ask when is the summer solstice on an exam, I would not be asking is it June 20th or June 22nd or June 23rd. That's just cruel. I would be saying is it March or June or May, something like that. Alright, so summer solstice, mid to end of June. Now what's happening here, and you can see the Earth, it's the far left in the picture there. The sun's rays are pointing directly, and that nice little arrow kind of helps you figure it out, pointing directly at the Tropic of Cancer. That's about 23.5 degrees north latitude. So for the northern hemisphere, it's actually producing the longest day. For the southern hemisphere, it's actually producing the shortest day. But we won't try and wrap our heads around both of that. Let's just go with northern hemisphere, longest day, summertime, June, Tropic of Cancer. Okay, and a solstice. So here's the other solstice. On the other hand, the right there, you can see it. Winter solstice. December 21st, 22nd, winter time, right? And thanks to that little arrow there, you can see that the sun's rays are directly on the Tropic of Capricorn. This is the southern hemisphere, 23.5 degrees. Okay, so for us in the northern hemisphere, this is the shortest day. Alright, moving on to equinoxes. Just like I had said, basically it means equal night. So the nights and the days are the same length. Okay. First one we're going to look at is the fall or autumnal equinox. Happens in September. So this is the bottom Earth picture, if you will. And the ray, you can't exactly see where the ray's pointing to. If you kind of look at the top one, you'll be able to see it's pointing to the middle line in the middle of the Earth, the equator. Okay, so in both cases, they're pointing to the equator, which means that everyone's getting an equal amount of light and an equal amount of dark on that one day. So that's the autumnal or the fall equinox. Lastly is the spring equinox or the vernal equinox. This happens in March, and can you guess what's happening? I'm not there, so I'll just pretend you answered. The rays are on the equator, which means we get equal days and equal nights for the entire Earth. Okay, so spring, equinox, equal days, equal nights, March. And you can see it's at the top Earth there, if you will.
Twice a year, day and night fall into balance, lasting for nearly equal lengths. Known as equinoxes, Latin for equal night, they occur in March and September, and along with solstices, mark the changing of seasons as Earth travels around the sun. Astronomers like to describe the equinox within the conceptual celestial sphere. Here, the heavens are projected around the Earth like an enormous planetarium. The model is bisected by the celestial equator, a projection of Earth's own equator. The equinox occurs at the point at which the sun's path, or ecliptic, crosses the celestial equator. In spring it is known as the vernal equinox, and in fall, the autumnal equinox. The other two seasonal points on the sun's path are the two solstices. In the northern hemisphere, the summer solstice marks the longest day of the year, while the winter solstice marks the shortest. The seasonal aligning of the sun has been more than just a unique celestial event for humankind throughout history. Ancient sites like Stonehenge in England and Machu Picchu in Peru have well-documented solar alignments during the solstices. Similarly, the equinoxes have been associated with some amazing man-made phenomena. In the ancient Maya city of Chichen Itza, the Great Pyramid known as El Castillo is oriented along cardinal axes. During the equinoxes, shadows cast by the railings create the illusion of a writhing serpent body descending the northern steps where it joins the carved serpent's head at the base of the stairway. The cultural significance of the fall equinox and changing of seasons continues today, especially in the northern hemisphere, where the autumnal equinox occurs around harvest season. In fact, the full moon nearest the autumnal equinox is commonly referred to as the harvest moon. In China and other Asian countries, this time is celebrated with the Mid-Autumnal Festival. The origins are linked to the birth of the moon goddess, and festival traditions revolve around families with reunions and feasts, and special moon cakes. In Jewish culture, thanks for the harvest is given during the week-long Feast of the Tabernacles, or Sukkot. Families eat meals in temporary shelters outside, recalling the Israelites' days in the wilderness after the exodus from Egypt.
And again, hopefully you watched that video. This picture here is kind of a more direct picture of the solstices and equinoxes. You can pretty much tell, I know they're labeled, but if you just kind of look at the tilt of the Earth on them, you could tell which one is a solstice and which one is an equinox. The ones that are tilted, your sun's rays are at 23.5 degrees directly on them, and the ones that's not tilted, that's your equinox. The sun's rays is at the equator for the equinox. Personally, I think the equinoxes are the easiest to remember because it's on the equator and it means equal, equinox, equal night, right? The solstice, to me, it's just, oh, that's the other one. That's just how I remember things. Obviously, people remember things differently, but just a little hint if you were looking for that.